This question was in your homework, and it's actually a review from precalculus, or maybe at your school that was called college algebra. Let me walk you through this type of problem from precalculus. And by the way, this is covered in our textbook. It's in the appendix, and let me show you how I found that. If you're in the textbook, you've opened up the e-text, then you could open the menu, and that gives us a table of contents. And when you scroll down, you see that the appendices include arithmetic and geometric sequences. And this is where, when I go to B2, this is where I could get a little more help with this type of question. So you'll see that in this textbook, one of the pages, or one of the formulas we get, is the sum of a finite arithmetic sequence, and then what we're going to look for is the sum of a geometric sequence. Here we go. And so this formula, theorem 5, is a formula that we'll use for our example. Let me take you to the notebook here, and we'll work through this problem together. The first step is to pull out the formulas that we're going to need. We could use these two formulas, the sum of the geometric sequence and the nth term of a geometric sequence. We could use these two formulas for almost any of the different questions you might come across using a geometric series. So this first, let me highlight them so that you can see what I'm referring to. This first equation or formula gives us the sum, and that's what this question is asking us to calculate a sum. But one of the things that we're going to need, if you look at what we need from this formula, we're going to need to know the first term. Well, we know that, that's 4. And we need to know what the ratio is. We can determine the ratio as 1/3. I'll explain that a little bit more in just a minute here. But what we don't have is which term is this 4/65/61. So how many things are we adding together when we get there? So for example, let me switch to a pen here. This 4 is the first term. This 4/3 is the second term. 4/n is the third term, so on, right? So we can see what the different terms are, but which n is the 4/65/61? How many pieces are there in this ellipsis? So in the in-between, how many different fractions would we have in there in that ... before we got to the 4/65/61? And that is where we'll use this a sub n. The nth term is 4/65/61. So what is n? Okay, let's get started with this. Now, just some initial pieces. I can get that a is equal to 4, and this a refers to whatever the first term is. So a sub 1, or a, is simply going to be 4. That's our first term. The ratio, so that's when we go from one term to the next, what did we multiply by? So 4 times what? Let's say x equals 4/3. We could use this 4 and x and 4/3 to solve for x. So x equals 4/3 divided by 4. And we get 1/3. And then we could use that 1/3 to check. So let's check it. Is 4/3 times 1/3, is that giving us the next term? And you find that yes, it does work. You could try this with the 4/9 and the 4/27. If I multiply 4/9 times 1/3, do I get the 4/27? Well, let's try it. 4 times 1 is 4. 9 times 3 is 27. Yes, that did work. So what I've determined is that the ratio, the R, is 1/3. That ratio, the R, means what do we multiply one term times to get the next term? So what do I know? I know that the first term is 4, and I know that the ratio between terms is 1/3. If I plug that in to calculate the sum of n terms, I'd get 4, I'm right here, 4 times 1 minus 1/3 to the n over 1 minus 1/3. Now 1 minus 1/3 is 2/3. 3/3 minus 1/3 is 2/3. And then if I multiply the 4 times 3 and divide by 2, I'd get 6. Or in other words, if you're needing a review on this arithmetic, it's 4 divided by 2/3. That's the same thing as 4 over 1 times 3 over 2. So 12 divided by 2 is 6. So I get that the sum is 6 times the quantity of 1 minus 1/3 n. Or I could say that it's 6 minus 6 times 1 over 3 to the n, right? But one way or another, you see that what I need to find is n. So let's do a little bit of precalculus to find n. If I use this formula, the nth term is equivalent to the first term times r to the number of terms less 1. Then I could see that a sub n is equal to 4, because our first term is 4, times 1/3, because our ratio is 1/3, to the n minus 1. Now, I'm going to, just to keep this a little bit simpler, I'm going to substitute in an x for this n minus 1. You don't have to do that. You could keep this n minus 1 here. But just to make it as simple as I can, I'm going to use an x for that n minus 1. And then once I know x, it'll be easy to go back and find what's n minus 1. So here's what we have. Our first, or not first, our last term, our a sub n, is 4 over 65/61. And remember what we're trying to determine. We're trying to determine which term is this, or how many n's are there. So if I let a sub n equal 44 over 65/61, and I set that equal to 4 times 1/3 to the x, I could divide both sides by this 4, divide both sides by 4, and that 4 over 4 divides out, so I have 1 over 65/61 equals 1/3 to the x. Now, I don't know if this stands out to you or not, but here's the mnemonic that I've used in precalculus to help students remember how to solve this. Here's the mnemonic. How do you get an x out of the tree? Does that sound kind of crazy? You've got your x, kind of like a frisbee, up here in the tree. How do you get it out? The answer is you throw a log at it. I don't know if you've already knew that to get that x, if the missing piece is an exponent, what you do is you take a log of both sides. Maybe you already knew that. If you didn't, if you were staring at this part thinking, I don't know what to do from here, then this mnemonic, how do you get the x down from the tree? How do you solve for x when x is up in the tree, or up as the exponent? The answer is you throw a log at it. We use a log. I'm going to use a natural log, ln. So in other words, to solve for x, I simply take the natural log of both sides. I could also do the log base 10, so that's just the log, but I'm going to use ln because there's really no reason. You could just as easily do log. If you solve this, the natural log of 1 over 6561 equals the natural log of 1/3 to the x, then what happens is this x, when we do natural logs, comes down in front. Let me just show you this arithmetic. I'm gonna put that ln 1 over 6561 in the calculator, and then I'm going to divide that answer by ln 1/3, and that's going to give me the x. But when you do that calculation, you get that x equals 8. If you need a little more help with logs, I'm going to encourage you to work with a tutor, because maybe it's been a while since you've done logs, or maybe you covered that in precalculus but never really understood it or got enough practice with it. So if you need just a little bit more practice with it, that's fine. Just get that extra practice you need. You'll need that log and natural log. You'll need to be able to work with those for future math classes as well if you're going into finance or business. So it might benefit you to get that review now. But once we know that that x is equal to 8, I can see that if x is n minus 1, then n, if 8 equals n minus 1, then adding 1 to both sides, I'd get 8 plus 1 is 9. So in other words, n must equal 9, because 9 minus 1 gives me the 8. Okay, we're well on our way. We know that n is 9. So I can, in my search for the sum of, now I can fill that n in with 9. The sum of the first 9 terms is going to be 6 times 1 minus 1/3 to the 9th power. So to do this calculation, it's all calculator from here. I'm going to do 1/3 to the 9th power is equal to 1 over 3 to the 9th power. So that's 1 over 19,683. And if I subtract that from 1, could you see this, that 1 could be 19,683 over 19,683 minus 1 over 19,683, and that was all times 6. And so this fraction is going to come to 1 less than that. So 6 over 1 times 19,683 minus 1, so 19,682 over 19,683. We're nearly done now. We just have to see if this doesn't reduce in some way. And that 6 can be divided by 2 or 3, and I can see, let me make this 3 a little more clear. I can see, since this is a 3, it's odd. I know I can't divide by 2, but let's check if I can divide by 3, because 6 is equal to 3 times 2, right? So if I do divide the 6 by 3, I'm left with 2, and if I divide the 19,683 divided by 3, let me type that into the calculator here, then I get 6,561. So it did actually reduce, didn't it? So our final answer is going to have the 6,561 in the denominator. And if I do 2 times 19,682, I'd get the numerator. Let me type that in the calculator, and I get 39,364, and that is our correct answer. Now again, this was a review from precalculus, so maybe you need to brush up on that a little bit, but I hope that this video has helped you walk through that problem.